My name is Michael, and I will be talking about kinematics, specifically vectors and scalars. So first of all, this is my first video, and we will be doing this on kinematics. So basically, kinematics is just like a branch of physics that describes the motion of objects without considering the forces that cause the motion. It focuses on concepts such as position, displacement, velocity, acceleration, and time. So kinematics is the study of like how things move. So first of all, we need to talk about vectors, okay? And scalars. So let's just imagine that you're giving directions to a friend to, let's say, find a hidden treasure in a park. So this is your friend, and this is you. And you are giving directions to your friend to find a treasure beneath the park. Okay? Now you tell them to walk, so you tell them the directions basically. And you basically tell them to walk 50 meters and then turn left and then walk another 30 meters. And then dig under the big oak tree, which is this tree right here. Now, in these directions, we've used two types of quantities. Some just have a number like the 50 meters right here, and others have both number and direction, like here when he said turn left. These two types of quantities are what we call vectors and scalars. Let's start with scalars. Scalars are quantities that are fully described by their magnitude or size. In, in our treasure hunt example, the distance you told your friend to walk in, for example 50 meters and 30 meters, are scalar quantities. So our scalars in this case would be 50 meters and 30 meters. Thing about these scalars is they only tell us how big or how much it is. They don't tell us anything about the direction. So in essence, scalars are like the magnitude of something. They give us a sense of how big or small a quantity is, but they don't tell us anything about the direction in which it's happening. Vectors. Now let's talk about vectors. Vectors are quantities that have both magnitude and direction. In our treasure hunt, uh, when we said turn left, we not only gave a direction, which is 30 meters, but also a direction, which is left. The combination of magnitude and direction makes it a vector quantity. Okay? Another example of a vector quantity is velocity. If I tell you a car is moving at 50 kilometers per hour, that's just a scalar because all I'm telling you is that the car is moving at 50 kilometers an hour. I'm just telling you its speed, and that's about it. But if I tell you where the car is going, which is north, it would make it a vector quantity. So the key difference between a vector and a scalar, to summarize, vectors have both magnitude and direction, while scalars only have magnitude. Scalars are like the how much of a quantity, while vectors are like how much and in which direction. Understanding the distinction between vectors and scalars is crucial in physics and many other fields because it helps us accurately describe and analyze various phenomena, from motion to forces to electromagnetic fields.